Okay, let's try to show that this has two positive and two negative roots. Okay, let's get the turn-in points. 4x cubed minus 6x, that needs to equal 0. Take out 2x, that leaves me with 2x squared minus 3, that should equal 0. That means x is 0, or x is the square root of 3 over 2, or x is minus the square root of 3 over 2. That would mean that y is 1, or y is, let's see, 3 over 2, let's do a bit of rough work on the side here. 3 over 2 squared, 9 over 4 minus 9 over 4, oh, that's 1 as well. And then the last one should be 1 as well. Interesting. Interesting. So a very rough sketch. 0, root 3 over 2 minus root 3 over 2, and as a turning point, and its height is 1. Or it could actually be saddle points. Let's get the next derivative. That's 12x squared minus 6. That's a positive in the first case. So that means it's convex. Oh no, sorry. When x is 0, it's a negative, so that's convex then. Maybe my y values are wrong here. Root 3 over 2 squared 9 over 4. Oh, it is wrong. It's not 1. That's wrong. Let's try that again. 9 over 4 minus 3 times 3 over 2 plus 1. It's 9 over 4 minus 9 over 2 plus 1. That's 9 over 4 minus 18 over 4 plus 1, which is 4 over 4. So that's minus 9 over 4 plus 4 over 4, which is minus 5 over 4. Okay. Minus 5 over 4. And it has to be the same for the other one. So if I draw that now, 0, 1 would be like here, and then the next one, root 2 minus would be there, and then there'd be another one here, and so it has to be going like this. Yeah, okay, so I can see why there has to be 4 now. So we just need to find a value far enough to the left and to the right. So this distance here, 3 over 2. Yeah, okay. So if we just put together a table here, x, f of x, so minus 2 root 3 over 2, minus root 3 over 2, and 0, root 3 over 2, and 2, root 3 over 2. So we know for this one here, we get positive 1. This one here, we get a negative 5 over 4. This one here, we get a negative 5 over 4. And let me just check what the 2, this one here would be. So 2, 4, 8, 16 times 9 over 4 minus 3 times 3 over 2 plus 1. Oh. 36 minus 9 over 2 plus 1. So that's 37 minus 4.5, which is definitely a positive then. That's over 2. 35, 74, 65 over 2, I think. 35, 74, 65 over 2, I think. Anyways, it's positive for sure. $65 over 4 positive, and then positive 65 over 4. So intermediate value theorem implies a root in between these two, and then intermediate value theorem implies a root here, and then intermediate value theorem implies a root here, and then intermediate value theorem implies a root here. And this is in the negative region. And yeah, these two would be negative, and then these two positive. So 2 negative and 2 positive roots. And none of these values were the root, but the roots would be in between. So there'll be a root in between these two and in between these two, and that's all negative, and in between these two and in between these two, and that's all positive then. Okay, I wonder if I can graph this now. Let's see. X power 4 minus 3x squared plus 1. Yeah, let me paste this in now. Oops. Okay. Yeah, we can see the roots here, 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 and here.